The future of AI is now, and we're bringing it to you first. This week, we've got an AI that turns any video into a 4D scene, letting you explore different angles and perspectives. We've also got an AI that tracks objects with amazing precision, even in the most complex, high-speed action. And that's not all. Open source models is pushing new limits in video enhancement. Let's dive in. Let's dive into some fascinating examples from the CAT4D project. Imagine taking a single input video and being able to explore it from entirely new perspectives and moments in time. The 3D scenes from their demonstration showcases this capability beautifully. What you're seeing is a set of dynamic 3D scenes generated from just one monocular video. What's even cooler is that CAT4D provides a depth map alongside these renderings. This depth map helps us visualize how the AI interprets spatial relationships in the scene, adding another layer of richness to the generated outputs. Despite the complexity, CAT4D maintains remarkable consistency across these scenes. Even when the input only partially captures a subject or object, the model intelligently reconstructs the missing views. This means it has to infer details like the hidden sides of an object or subtle shifts in motion over time. Now, this isn't just about replaying a video. It's about recreating it as a fully dynamic 3D environment. You can adjust the camera's position, angle, and even the moment in time you want to view, opening up a host of possibilities for applications in virtual reality, filmmaking, and beyond. However, extreme camera angles and occlusions can still pose challenges, occasionally resulting in deformations or artifacts. But considering the groundbreaking ability to generate multi-view, time-varying scenes from just a single video input, CAT4D represents an incredible leap in AI-driven 4D scene reconstruction. CAT4D, developed by Google DeepMind, is an AI tool that transforms a single monocular video into a dynamic 4D scene. Using a multi-view video diffusion model, CAT4D generates high-quality, consistent 3D reconstructions from any video, enabling users to explore different perspectives and moments in time. The AI not only estimates missing details but also intelligently handles camera movement, producing smooth, immersive experiences. By optimizing a deformable 3D Gaussian representation, CAT4D offers powerful capabilities for industries like film, gaming, and augmented reality, turning simple videos into fully interactive 4D environments. One of the most exciting features of CAT4D is its interactive capability, allowing users to explore 4D scenes in real time. On the CAT4D website, you can engage with the generated 4D scenes through interactive demos, where you can manipulate the viewpoint and time to see how the scene changes from different angles and at various moments. This interactivity is a game changer for anyone working with dynamic 3D content, as it provides a hands-on experience with how the AI reconstructs and synthesizes the scene from the input video. Looking at the examples, we can really appreciate the power of this tool. Each example showcases a dynamic 3D scene reconstructed from a single monocular video. The rendered images are arranged in a grid, with the vertical axis representing different time steps and the horizontal axis showing varying viewpoints. As you drag across the grid, you can see how the scene evolves over time and how the camera angle shifts, offering a partial 360-degree view of the action. The depth map at the bottom right of each example gives us a sense of how the AI understands the spatial relationships within the scene, adding another layer of realism to the generated output. What's truly impressive here is the consistency. As you interact with the video, you'll notice how the AI maintains smooth transitions across both time and viewpoint. Even when you focus on more complex movements or hidden angles, like when characters turn or objects are partially occluded, CAT4D works its magic to reconstruct those missing details in real time. This consistency is crucial, as traditional 3D rendering methods often struggle with occlusions or missing data, but CAT4D uses learned priors and sophisticated sampling strategies to fill in the gaps. However, while the tool performs admirably, there are still some imperfections, especially when making extreme camera movements or viewing from difficult angles. For example, if you move the camera too far behind an object or rotate it rapidly, you might notice some minor deformations in the scene. These are typical challenges in any early-stage 3D reconstruction system. But what makes CAT4D stand out is how well it handles more subtle camera shifts, providing a smooth, immersive experience when you're just exploring the scene with slight movements. One of the standout features of CAT4D is its ability to separately control camera viewpoint and time, which opens up a whole new level of flexibility when working with dynamic 3D scenes. In traditional 3D scene reconstruction, camera movement and scene changes are often tightly coupled, making it hard to manipulate them independently. But with CAT4D, this challenge is tackled head-on, allowing users to adjust each factor independently, giving them precise control over both the viewpoint and the timeline. In the first demonstration, we see how CAT4D handles a fixed viewpoint with varying time. This means that while the camera stays in the same position, the scene evolves over time. As you look at the generated frames, you can observe how the dynamic elements within the scene move and change, all while maintaining a consistent viewpoint. This is perfect for scenarios where you need to capture the motion of objects or characters from a single perspective, like in surveillance or certain film sequences. Moving to the second example, we see how CAT4D enables varying viewpoints with a fixed time. In this case, the scene remains frozen in time, but the viewpoint shifts, letting you explore the 3D scene from different angles. This is incredibly useful for applications in virtual tours, where the user might want to navigate around a static moment in time, such as inspecting a particular object or character from multiple directions. You get the sensation of walking around the scene, all while maintaining a time-stable snapshot of the action. Finally, the third example demonstrates the power of fully disentangled control, where both the camera viewpoint and time are allowed to vary. This gives users complete freedom to explore both the spatial and temporal aspects of a scene independently. In this mode, you can freely navigate the 3D environment and adjust the timeline as if you were able to rewind, fast forward, or reposition yourself within the scene at will. One of the key innovations in CAT4D is its ability to provide separate control over both camera viewpoint and time. In this first demonstration, we see the impact of this feature. With a fixed viewpoint, CAT4D allows time to vary, creating a bullet time effect. This lets you watch how the scene evolves over time, while the camera remains stationary, giving you an excellent view of dynamic changes without shifting perspective. The second scenario shows the opposite. The camera viewpoint shifts while time stays fixed, so you can examine the scene from various angles at a single moment in time. Finally, in the third demonstration, both camera and time change simultaneously, giving you complete freedom to manipulate the scene in any direction. This level of independent control over space and time is perfect for applications in virtual tours, storytelling, and dynamic simulations, where flexibility and precision are paramount. Next, let's explore how CAT4D handles sparse view bullet time 3D reconstruction. Here, the task is to reconstruct a 3D scene from only a few input views. The example in the second demonstration shows how CAT4D takes minimal data and generates high-quality, consistent multi-view videos at different timestamps. Notice how the system reconstructs dynamic scenes even with sparse input, allowing the scene to be viewed from new angles and times. This is crucial for situations where full coverage of the scene is unavailable or impractical, such as in live recordings or security footage. With the ability to extrapolate data from limited views, CAT4D successfully fills in the missing information, producing smooth and coherent reconstructions that can be manipulated for further exploration. The bullet time effect, in particular, showcases its strength in handling dynamic motion from a small set of input images. Finally, CAT4D excels at 4D reconstruction, turning monocular video into full 3D models that evolve over time. The third task demonstrates how CAT4D can take a single video and reconstruct a dynamic 3D scene, effectively transforming a 2D video into a complete 4D experience. In the example, we see how the AI optimizes the scene using a deformable 3D Gaussian representation. This allows for smooth and continuous changes in the scene across time, creating highly realistic 4D content. The system works by generating consistent multi-view videos from the monocular input, which are then used to build a dynamic 3D model. This is a major step forward in AI-driven 3D reconstruction, making it possible to create lifelike 4D scenes with minimal data. The result is not only impressive, but also applicable to industries like film, gaming, and AR, where real-time dynamic content is needed. They've just released it, so there isn't a Hugging Face or GitHub link available yet. However, I'll be sure to announce it if they do release the code, and I might even create a tutorial on it. Stay tuned for updates. In the meantime, I'll link to the main page in the description below. Next, introducing Generative Omnimatte, an AI tool designed to seamlessly separate and manipulate video elements with precision. Developed by a team of AI researchers, this tool leverages advanced deep learning techniques to create high-quality, generative models that can autonomously isolate and reconstruct objects within a video. With its unique ability to generate realistic 3D renderings of individual components from dynamic scenes, Generative Omnimatte has enormous potential for a range of industries, from film production to augmented reality. The tool works by generating high-fidelity masks for various elements in a video, which allows for easy manipulation, replacement, or editing of those elements while maintaining the realism of the scene. This level of isolation is essential for tasks like special effects in movies, virtual set creation, or even altering the background in live-action shots without disturbing the foreground. By generating separate layers of the scene, Omnimatte provides full control over video composition, offering creators the ability to modify objects and environments with remarkable flexibility. We can see several examples that illustrate the tool's powerful capabilities. The examples show how Omnimatte can accurately separate the foreground subject from a complex background. Notice how the AI has not only isolated the person in the video, but also maintained the natural edges of the subject, avoiding any unnatural cutoff points that are often seen in traditional masking techniques. The tool demonstrates the ability to generate realistic reflections and shadows for the isolated objects, making the scene look as if the objects were always in place. This makes the editing process far smoother, especially when creating composite shots that require interaction between objects and their environment. The examples highlight how Omnimatte works with multiple objects within a scene, maintaining consistency in both the foreground and background elements. The AI ensures that even when objects move or interact, the generated masks remain accurate and adaptable, allowing for real-time adjustments and edits. The tool is packed with powerful features that give creators complete control over their videos. Object removal allows you to seamlessly erase unwanted elements from a scene, automatically filling in the background as if the object was never there. Need to change the setting. Background change lets you replace the background with anything, from images to dynamic video, while keeping the foreground intact and natural looking. The tool also supports duplication, allowing you to replicate objects or characters within the scene. This is perfect for creating crowd scenes or adding multiple reflections. And with layer insertion, you can add new elements, like text, animations, or objects, into a scene without disturbing the existing content, ensuring everything blends smoothly. From removing distractions to creating complex visual effects, the tool offers an intuitive and powerful way to edit dynamic video content. Let's take a look at how different tools in the suite compare for background and foreground manipulation. Starting with Omnimatte, this tool is a powerhouse for traditional video editing, excelling at object isolation, background removal, and foreground manipulation in 2D space. It generates high-quality masks for accurate separation, allowing you to remove, change, or duplicate objects seamlessly. It's perfect for simpler tasks where you need precision and flexibility in a 2D environment. Next, we have OmniParser 3D, an advanced version designed for dynamic 3D environments. Unlike its 2D counterpart, OmniParser 3D can isolate and manipulate objects in three-dimensional space. This is especially valuable for scenes with depth or when working with virtual environments, where the interaction between foreground objects and background elements is more complex. With OmniParser 3D, you can maintain realistic lighting, shadows, and perspective shifts, giving your edits a true 3D feel. Then there's OmniParser RF, which integrates with radiance fields to further enhance your scene manipulation. This tool extends the capabilities of OmniParser 3D by using volumetric data to create more realistic edits. Whether you're altering lighting, changing object positions, or shifting the camera angle, OmniParser RF leverages radial technology to generate highly detailed, photorealistic results. It's a choice for high-end visual effects, particularly in cinematic or immersive AR or VR experiences. Finally, we have FactorMatte, a tool built for more sophisticated scene parsing, focusing on foreground-background separation. FactorMatte uses deep learning models to segment videos into multiple factors, such as color, texture, and motion, which allows for deeper control over each layer of a scene. It's perfect for complex editing tasks, such as creating multiple versions of a scene or working with scenes that have complex interactions between foreground and background elements. In summary, OmniMatte is perfect for precise 2D object manipulation, while OmniParser 3D takes it further into the 3D world. OmniParser RF pushes the boundaries with radiance fields for photorealistic edits, and FactorMatte offers in-depth control for advanced scene manipulation. Each tool serves a different purpose, giving you the flexibility to choose the right one for your project's complexity and creative needs. Let's dive into the comparisons of different tools for object and effect removal and how they stack up against each other when it comes to dynamic video editing. First, we have ProPainter, a tool that specializes in object removal and repainting. It's particularly effective for removing unwanted elements from a scene, like props, people, or even large background distractions. ProPainter fills in the gaps left behind by seamlessly repainting the removed area with context-aware textures. Next up is Lumia, a generative tool focused on animating and editing objects within the scene. Lumia excels at transforming static images or objects in a video into dynamic elements, which is particularly useful for removing or replacing background objects while keeping the foreground elements intact. Then we have Object Drop, which specializes in both the removal and replacement of objects in a scene. Unlike traditional masking tools, Object Drop generates realistic replacements for the removed object, ensuring that the edited scene blends seamlessly with its environment. Now, an important part of the development process for these tools is the ablation study on training data, particularly the CAT4D dataset. The ablation study explores how different types of training data impact the performance of object removal and scene reconstruction. CAT4D, which is a carefully curated dataset, plays a crucial role in ensuring that these tools can handle complex backgrounds and objects. The study helps identify the best data combinations, allowing for more accurate scene parsing and smoother object removal. However, as with any AI tool, there are limitations. These tools, while incredibly powerful, can still struggle with highly complex scenes where objects overlap or where there's significant motion blur. Extreme occlusions or fast-moving elements might also present challenges, leading to minor artifacts or inaccuracies in the mask generation. Next, introducing InstantIR, an AI tool that makes images clearer and more detailed in real time. It works by using artificial intelligence to improve low-resolution or noisy footage, turning it into high-quality images. This is especially useful in situations where traditional images are blurry or hard to read, such as in security cameras, medical scans, or even nature monitoring. The method behind the tool uses AI to clean up the image, making the details stand out more clearly. It reduces noise, fills in missing information, and sharpens the image, making it easier to see what's happening in the scene, even if it's dark or unclear. Take a look at the two examples. In the raw image, the images are hard to make out, it's blurry and lacks detail. However, with this tool, the image becomes much clearer. You can now see the body's shape and features much more clearly. This shows how the tool can enhance footage to make it more useful in real-world situations, whether you're tracking wildlife or using it for safety or medical purposes. Let's check other examples which show the utility of this AI image enhancer. We can check the improvement and the clear interpretation of the input blurry images from left to right where they are rich in details with global semantic consistency. Also, the tool can incorporate the use of prompts to guide the model for better enhancements and modifications. The AI tool is now available on GitHub. The space demo is live, allowing you to try out the tool directly in your browser and experience its capabilities with ease. For those who want to use it locally, a Gradio launching script is now provided, making it simple to deploy the tool on your own machine. Let us know if you are interested in a separate tutorial video for this tool to guide you on the local installation in the comments below. The tool is also now compatible with diffusers, giving you access to powerful features from this package. Plus, the code and model have been released, built on SDXL and DIO version 2, and you can download them directly from Hugging Face or use the Python package to integrate it into your projects. With these updates, the tool is easier than ever to explore, deploy, and use in your own work. Now, let's explore some examples on the Hugging Face platform to showcase the incredible utility of this AI image enhancer. This tool is not only capable of restoring broken or damaged images, but also has the ability to creatively reimagine your images based on your text prompts. Whether you're fixing an old photo or generating new content, the tool brings your vision to life. For basic usage, revitalizing your image is easy. Simply upload the image you want to restore, and by default, the tool will work its magic to restore it at the original size. If you need a different resolution, you can adjust the output size by setting the height and width values. Setting the dimensions to 0 will keep the original size intact. You can also fine-tune the quality by adjusting the steps and CFG scale parameters. Higher step values typically lead to better results, but to balance quality and speed, they recommend setting the steps between 30 and 50. Once you're ready, just click on InstantIR Magic and watch as the tool enhances your image with remarkable detail and clarity. For more advanced usage, The tool goes even further, allowing you to push the boundaries of creativity by following your custom text prompts. Check out the advanced usage section for more details and instructions. Let's move to another AI tool in our list, introducing Material Anything, an AI tool designed to transform the way we work with 3D objects and materials. Created by a team of experts in artificial intelligence and computational design, Material Anything allows you to generate highly realistic 3D materials and textures from scratch without the need for traditional modeling or scanning. What makes Material Anything so powerful is its ability to create texture-less objects and convert them into realistic, fully textured models. Whether you're working with albedo-only scans or generated objects, this tool uses advanced, deep learning techniques to apply material properties, textures, and details that bring the object to life. With generated and scanned objects, Material Anything can seamlessly integrate into any creative pipeline, making it easier than ever to enhance 3D models with realistic materials. Using cutting-edge AI algorithms, Material Anything can take a simple, texture-less model and add realistic surface details, including complex textures, colors, and reflections based on the albedo maps and other inputs. Whether you're building assets for games, movies, virtual environments, or industrial design, Material Anything provides a quick and efficient way to create and refine materials, eliminating the need for time-consuming manual work. This tool combines AI-driven techniques with practical utility, making it an essential tool for artists, designers, and developers who want to streamline their workflows and create visually stunning 3D objects with minimal effort. For texture-less objects, which are simply 3D models without any surface detail, Material Anything uses advanced AI to generate realistic textures from scratch. This means you no longer have to spend hours manually creating textures. Material Anything handles it for you, adding details like bumps, wrinkles, and even subtle surface variations that bring your models to life. This is especially useful for designers and developers who need to quickly create 3D assets without needing to worry about texturing each model by hand. When it comes to albedo-only objects, which are 3D models with basic color information but no material properties like roughness, glossiness, or reflection, Material Anything steps in to fill the gap. The tool takes these simple albedo maps and enriches them by adding realistic material properties, allowing your models to look more lifelike. For instance, it can apply different levels of reflectivity to surfaces, making them look like glass, metal, or rough stone based on the object's shape and context. This is perfect for quickly bringing objects up to production quality, especially when working with game assets or virtual environments. For generated objects, Material Anything excels at creating highly detailed 3D models from scratch based on simple inputs or shapes. Whether you're designing a character for a game or a product for a virtual space, Material Anything generates realistic textures and materials that would otherwise take time-consuming manual work. When working with scanned objects, which are often captured using photogrammetry or other scanning methods, Material Anything enhances and refines the scanned data. Scans can sometimes be imperfect, with missing textures or noisy data. Material Anything intelligently fills in the missing material details, ensuring the object looks as realistic as possible by improving surface textures, adding reflective properties, and correcting imperfections from the scan. This is invaluable for applications in virtual reality and augmented reality, where accurate, high-quality scanned models are essential for immersion. In comparison to traditional tools like Substance Painter, which requires manual texturing for each individual object, Material Anything offers a more automated and dynamic approach. While Substance Painter excels at detailing textures, it still requires artists to create and tweak textures for every single model. Material Anything, on the other hand, uses AI to automatically enhance your models based on the input provided, saving both time and effort. Material Anything stands out by offering users the ability to work with generated objects or custom textures. With Material Anything, you're not limited to pre-existing assets, and you can customize and enhance any 3D model, whether it's a simple shape or a complex scanned object. Material Anything is ideal for a wide range of industries and applications, including gaming, virtual reality, animation, film production, and industrial design. It allows artists, developers, and designers to work faster and more efficiently by automatically adding materials and textures to their 3D models. Whether you need to quickly texture a simple 3D object, enhance a scanned model, or generate detailed assets from scratch, Material Anything provides a flexible, efficient, and powerful solution. Material Anything is now available on GitHub. This AI tool for PBR material generation works with texture-less, albedo-only, generated, and scanned objects, enhancing your 3D models with realistic materials. In December 2024, they released the Material 3D dataset, featuring over 80,000 curated 3D objects with high-quality material maps and text descriptions. The dataset includes an object list and a caption list, plus a rendering script for Blender that creates material view, maps, and UV maps. To get started, install Blender 3. Newer versions may have compatibility issues. Visit GitHub to access the code and dataset and comment if you need a specific tutorial for this AI tool. Next, introducing Samurai, a powerful new tool designed to revolutionize object tracking and video analysis. The tool uses AI and deep learning techniques to track and analyze objects in videos with incredible accuracy and speed. Whether you're working with sports footage, surveillance videos, or any other type of dynamic scene, the tool provides a seamless solution for tracking moving objects, maintaining consistency across frames, and enhancing video editing workflows. The tool is equipped with an advanced tracking algorithm that excels in challenging scenarios, such as rapid movement, occlusions, and background clutter, as shown in this example compared to Segment Anything algorithm. Its robust design allows it to handle various tracking tasks, from simple object motion tracking to more complex multi-object tracking in dynamic environments. When comparing the tool with its predecessor, SIM 2, the tool offers several improvements in terms of accuracy and versatility. SIM 2 was already a strong tracker, but the tool takes it further by offering better handling of occlusions, faster processing speeds, and improved tracking stability in more complex environments. The tool's enhanced algorithm allows it to maintain consistent object tracking even when the object is partially obscured or moves at high speeds, which was more challenging for SIM 2. The results from the AI tool are impressive, showcasing its ability to track objects with high accuracy, even in challenging scenarios. Whether it's fast movement, occlusion, or complex backgrounds, the tool maintains stable and consistent tracking across frames. The tool outperforms previous models, offering smoother tracking and faster processing speeds, making it a game changer for video analysis and object tracking tasks. The official implementation of the tool, adapting Segment Anything model for zero-shot visual tracking with motion-aware memory, is now available on GitHub. To get started, you'll need to install SIM 2 first. The code requires Python, as well as Torch and Torch Vision. Make sure to follow the installation instructions provided to set up PyTorch and Torch Vision dependencies. The tool is optimized to run on GPU machines for faster performance. Now, let's check the last tool in today's episode. Introducing OmniParser, a cutting-edge tool designed to enhance vision-based agent systems for user interfaces as demonstrated in this example. Developed by researchers at Microsoft Research and Microsoft Gen AI, OmniParser tackles a major challenge in multimodal AI, helping large vision language models like GPT-4V understand and interact with user interfaces through screenshots. While multimodal models like GPT-4V have shown tremendous potential in driving agent systems across various applications, their effectiveness is limited by the lack of robust screen parsing techniques. OmniParser addresses this gap by enabling the accurate detection of interactable icons and the understanding of semantic relationships between different elements in a screenshot. This means that GPT-4V can now not only identify clickable regions, but also understand the functionality of each element, leading to more accurate and meaningful actions within the user interface. OmniParser works by parsing UI screenshots into structured elements. It leverages two specialized models, one for detecting interactable regions on the screen and another for extracting the functional semantics of those elements. To achieve this, the tool uses a custom curated dataset of over 67,000 images, which includes bounding boxes of interactable icons and 7,000 icon description pairs. These datasets were used to fine-tune the models, significantly improving GPT-4V's performance on benchmarks like ScreenSpot, Min2Web, and ITW. The results speak for themselves. OmniParser, using only a screenshot as input, outperforms the GPT-4V baseline, which requires additional information. By parsing the screenshot and adding local semantics, OmniParser enables more precise actions, grounding GPT-4V's responses to the exact regions on the screen. This makes it a game changer for developing more intuitive, vision-based AI agents. OmniParser has been evaluated on several benchmarks and has consistently outperformed previous models. For example, it achieved best performance on the Windows Agent Arena, showcasing its superiority in real-world applications. In addition, when integrated with GPT-4V, OmniParser has significantly improved the accuracy of actions performed based purely on screenshots without the need for external information. Additionally, OmniParser now includes features like fine-grained icon detection and the ability to predict whether screen elements are interactable, making it even more precise and versatile. The official code for OmniParser is available on Hugging Face, and the model is ready for use in your projects. They released OmniParser v1.5, which introduces two major updates: one, more fine-grained icon detection, allowing for the detection of smaller icons with greater accuracy, and two, the ability to predict whether screen elements are interactable, providing even more detailed control for vision-based agents. Thanks for watching. If you enjoyed this video, please give it a like and subscribe for more updates. Don't forget to check the description for free AI resources. See you next time as we explore new tools and innovations.